Hello everyone, myself Nikhil Mahajan and these are my friends Kunal and Aman. Our topic for assignment is blood glucose monitoring. So these are the research objectives that we have achieved. First, there are two very crucial parameters, the glycemic load and the glycemic index. Glycemic load is the measure of how much carbohydrate is present in the food. Ultimately, the carbohydrates get converted into glucose. Glycemic index is the measure of how quickly blood glucose level rises. Different food have different glycemic index. Some food have higher glycemic index, meaning when we consume these foods, our blood glucose level rises very quickly. Then we investigated the impact of insulin and its concentration on glucose level. Then we analyzed that how the glucose level is affected by the height, weight, gender, age, and exercise duration. Then we examine the influence of individual, whether individual is diabetic or not, on the glucose level, because this can have a, a strong correlation. Then we evaluated the impact of what medication or drugs a individual is taking, and it can also have a significant impact on glucose levels. Then we analyze the conversion of carbohydrates to glucose. Then we develop an analytical model to interconnect these variables like height, weight, the insulin release rate, its concentration, the medication. Then finally, we developed a machine learning model for simulation. Now, my friend Kunal, we continue.
Thank you, Nikhil. So now I'll discuss the modeling and simulation approach. So let me show you the data set which we have gotten from the from a research paper. So this is the data set which has very comprehensive data about the blood glucose levels and various other features which determine the blood glucose levels. So our target variable was the BG after value which we want to predict by the simulation or modeling. So now there were variables or features which were required for the prediction. So the features were gender, age, height, and is diabetic, that indicates whether the person has diabetes or not. Then the exercise duration or some medication or dosage information. Also some dietary information like carbohydrates and calorie intake, etc. So now what was our simulation approach? So this was the our flow of the simulation. So let me show the code which we have done for this. So yeah, this is our this is our Jupyter notebook, and here we have used machine learning approach to predict the BG after values. So here we can see we have imported the necessary libraries and then the data set, and then we have this information. So initially the data set has so many columns, around 26. So what we done was we plotted a heat map, and then we saw that there were some values which were null, so we deleted those columns and then got some pre-processing and checked the new info of the data set. So there were no missing values in the data set, so we proceeded further, and then we got this correlation heat map again. And here some values were highly correlated, so we dropped one feature and only kept the other which was highly correlated. So the clean data set looked like something like this. Here we can see there were 13 columns. Then we developed a linear regression model from the sklearn library of the machine learning. And here we used the train test split method, which splitted the data set. And here we can see the linear regression predictions, how it is predicting. And then these were the coefficient of the linear regression. So this was there. And then we again used a random forest model. Also, we can see these were the observations, like some were very highly correlated, positive correlations, some had negative, and finally we can write this equation which represents the VG after the mathematical relation with other features. Now I will ask Naman to continue.
So thank you, Kunal. So these are the outcomes discussed by the Kunal. Here the R square of our linear regression and the R square of random forest. Uh, I will suggest some future improvement in our model, like how we can enhance its accuracy. We can enhance its accuracy by adding some sleep and stress pattern to the dataset, providing valuable context for better blood glucose predictions. We can also do the real-time monitoring, which enhances the accuracy and relevance by using the latest data to predict glucose levels. We can integrate our model with the variable devices, such as we can connect the model with variable sensors for seamless monitoring with variable gadgets. We can improve the interpretability, uh, enhance transparency by explaining the model's decision-making process for easier understanding. We can also increase the robustness to external factors, strengthen the model's ability to withstand changes from diet, exercise, and medication. Uh, Now I will talk about some learning from the projects. Like the modeling complexity. Learn that blood glucose levels are affected by diet, activity, and medications, requiring complex model to predict accurately. Second, the data pre-processing. Uh, Understood the importance of pre-processing, such as handling missing data and normalizing the features which are crucial for model performance. Also, we have seen the how which algorithm we have to select linear regression or the random forest. We also done the hyperparameter tuning. Also, we have acquired the knowledge of machine learning, how the practically we can use the machine learning in our daily life. And last one is a collaborative learning. We just enjoy, we have fun making this project, and we have learned many new things about machine learning. uh, Thank you so much for being patient.